Hello, Block 4. Sorry we can't be here today, but I figured let's do a screencast and I'll go over the notes, which are pretty quick, and I'll move you right on over to your activity. So, we usually start out with picture of the day, so I figured I would go ahead and do that as well. I always look for this type of picture of the day, which is about our climate record for the previous year, sometime in the months of like February and March. Is usually when that data gets released, and NOAA did it this year. And so I figured let's go ahead and talk about that one. 2021 was the sixth hottest year on record in our modern recording time. So our modern recording time is right here. From about 1880 to 2021, weather data is some of the best scientific data that we have. And you can actually kind of see through this line that it is definitely and has been sloping upward for the past, I don't know, decades for sure, at least over more in my lifetime and definitely into yours. So the sixth hottest year on record. So after two consecutive years, 2019 and 2020, that ranked among the top three warmest on record, Earth was slightly cooler planet in 2021, but not by very much. So NOAA is the one that does this data. We have talked about that organization before, and they always try to take a look and try to see how much has gone up. And the increase has been pretty much in the most recent century about 1.5 degrees. Doesn't seem like a lot, but it's enough to actually do some stuff. I always think about I remember like the snow days as a kid when we used to get like a lot more snow, and our snow totals have been going down in recent years. And fun facts, the state of Connecticut has thought that they won't even have snow anymore in about the next 100 years or so. So like one day you will be a grandparent talking to your grandchildren, and you'll be talking about like snow days and what snow used to be like. And those, for them, it will be much decreased. And so I also like to bring up, it talks about the years 2013 and 2021 all rank among the 10 warmest on record. You guys are about 15, 16, born in about 2006. So you have actually also lived through about 15 of the 16 hottest years on record. So not even just the top 10, but almost pretty much the top 15. So it's been a lot. You did it. You made it through, and we continue to go on. So what can we do? As individuals, in all honesty, not a ton. We have to work to adapt to the world that we live in. And that's what this chart is down here on the bottom. So in this one, anything that is dark blue, that talks about it being record coldest, which there is none on the map. Anything that's lighter blue is a little bit colder on average. So a little bit of the Pacific actually was a little bit colder on average. For the most of the world, you can very easily see it's mostly red. The darker the red, that was the warmest year ever in that general region. So yes, it's definitely getting warmer for sure. So I know not the most positive picture of the day, but it is definitely one that will affect us for years to come. So we have not many notes to do today, just about 2 slides. I figured we'll do these ones, which is condensation and the factors that affect condensation. So we recently had just done evaporation, and evaporation is a cooling process. But I figured we should also do condensation, which is a warming process, which is written right down here. So hopefully these slides look very, very similar to the evaporation one, because it's pretty much the exact same thing. Instead of having water go from a liquid to a gas like it does in evaporation, it does the opposite. It goes from a gas form down to a liquid form, and we call that condensation. In order to do so, this is also written on your reference table, but in order for it to do so, it must release heat to its environment. So unlike evaporation, which is a cooling process because it's pulling in heat to the water, condensation is letting that heat out. So water is releasing heat to condensate, so warming the air that surrounds it while it does so. I think probably the time period where you see evaporation and condensation really going on the most, especially condensation, I put a little example down here, is usually during the summertime. Whenever you maybe go outside with like a water bottle, or maybe go to the restaurant, and like usually you have a cool drink, and I'll just draw you a quick sketch like over here on the side, and there's maybe some ice in it, and just kind of keeps you cool during the summertime. But what happens, if you leave that drink out often enough, is that over time you start to get these like tiny little droplets of water that form on the outside of that glass, right? And it feels, and it's like a little more wet on the outside of that glass, and that's condensation. So that's what we're talking about over into there. And the big thing I always like to bring up is that water that's on the outside of the glass does not come from the inside, right? But what is happening is that you have heat moving around. So While that you have that all that ice into there, what that's doing is that is actually taking heat energy, right, from the water itself, making the water colder, but it's also taking heat energy from the air and pulling it on into the ice. And if it pulls enough heat energy into the ice, then the ice will melt, and then eventually over time, then your drink would eventually warm back up. But in the meantime, the ice is actually pulling in that heat, cooling down the liquid. Also, though, it's cooling the air around the glass, right? And that's why when you pick up the glass feels cold. And so we talked yesterday about the dew point. So if you would take the temperature of that air right over into this section, and you're decreasing it, right? And then it goes down by 1 degree, 2 degree, 3 degrees, 4 degrees. Eventually, that temperature of that air will go down to the temperature to which relative humidity is 100%. And then that means that temperature that occurred is the dew point. And so once that temperature here goes down and then gets to the dew point temperature, so dew point, then that is when condensation will start to occur, right? That's when, for outside, and just recently we had a little bit of a snowstorm, and we'll probably have a little bit of a snowstorm on Saturday as well, right? Air temperature will decrease, decrease, decrease. It'll eventually hit the temperature to where water is totally, and the air is totally saturated with water in the sky. That's relative humidity would be 100%. And then you start to get these little dewdrops that fall out of the sky, which we call precipitation, like rain or snow. But on the glass, you need to have it form right on the side. So it forms right on the solid parts of this little glass. So that's why during the summertime, I was thinking I would go to a restaurant, they give the glass of water, has some ice cubes in it. In the beginning, the outside the glass is totally dry, but like as time goes on, right, the air is being cooled around the outside of the glass. It's cooled to the dew point, and then condensation. And so that's what we were talking about today for condensation. And then let me go over to my next slide. And what affects condensation? The first one we've already kind of mentioned at least a little bit is that air must be saturated. If there's no water in the air, you can't have condensation, which means that the water would come out from as a gas down to a liquid form. It just can't happen. So think of like a desert. When you have eventually like a desert or a very, very dry day, there's no clouds in the sky because clouds are made out of water vapor, right? A glass saturated air, and they're just not up there because the air is too dry. So you need evaporation to occur. You need the air to be saturated. So to make clouds, you definitely have to have that saturated air. The second one, though, is usually a little bit of a surprise to people. It's called condensation nuclei. Condensation nuclei is a little piece of solid matter. It's tiny. It's incredibly, incredibly hard to see, but it's there, and it usually forms at the center of a condensation, so like a little droplet of precipitation. So what that is it can be really anything, just like a tiny, tiny, tiny little speck of something, right? It could be maybe a little bit of dust. It could be a little bit of dirt. It could be a little part of something, like maybe a tiny, tiny little cells of like a piece of grass. I put in here, it could also be like microplastic. It could be little bits of solid material, building material, like just tiny, tiny little specks of like organic matter, just anything. And they all float around up in the air all the time. And we breathe them in, we breathe them out. It's not really such a big deal. And you probably have seen this like when you think of like sunbeams in a house and those little things that float around like a little sunbeam in a house. That's the kind of stuff that we're talking about. Anyways, you have that little bit of solid matter up there in the air. And then what happens is that air temperature goes down, right? It gets colder, gets colder, gets colder. Eventually, the relative humidity is rising. Eventually, that relative humidity hits 100%, which happens at the dew point temperature. And then condensation will start to occur up in the sky, right? And you get all these like tiny, tiny little bits of like water molecules will start to form, and they'll form on that little droplet on that little speck of dirt or particles or something in the air, and it will build and will build and will build, and it'll cling right onto it, and eventually over time it forms your raindrop. And then that raindrop then gets too big, and then it falls out of the sky down to the ground, and that's what we have. And if it's really warm, it becomes rain. If it's really cold, it becomes snow. And if it's somewhere in the middle, maybe like sleet, freezing rain, something like that. So every piece of water that has fallen out of the sky, from like raindrops to snowflakes to hail, everything, all have a tiny, tiny, tiny little speck of something in the middle. So like if you ever caught like snowflake on your tongue or drank some like water out of the sky, it's not like pure 100% water molecules. There is a little speck of something in there. Does that hurt you? Is that bad for you? No, it doesn't do anything. Your immune system is great. It's not going to do anything. And it also um, is good because it actually pulls those particles out of the air. And if it's pulling those particles out of the air, it actually cleans the air for us. So it has to happen. So water, when it goes from a gas down to liquid, condensation, it must form on something. It can't just form in the middle of the air. It must actually form on a piece of something. So going back a slide to the one where I just talked about, my drawing is gone, but quick sketch again. We talk about like that water glass, and like how you had ice cubes, and over time you'd eventually have like your water droplets forming on the outside of the glass due to condensation, right? Why does it happen on the glass, and why not just in the middle of the air, and fall down? Like, why wouldn't you get like a little rain cloud right next to your glass? Is because water needs something solid to cling on to when it goes from a gas form back down to a liquid form. And so that would be at the restaurant, like your glass of water. And that's why you won't just get like a little random rain cloud right next to your glass. Not possible. All right, sounds good. So people are always usually surprised that like there's stuff in the rain. There's things in the rain. Like, yeah, there's things in the rain. And so what we're kind of working our way up towards, and this is like, a little bit of foreshadowing for next class, is we're going to work on like how do clouds form, right? And it's really just a big combination of everything we have done so far. And I wrote it right down here in like these little steps right down there. So it doesn't seem like a lot of steps, but I feel like we over the unit have broken it down to little pieces, so we have a better idea of like how this works. And I'll give you a quick overview right now. Is that warm air? It all begins with warm air somewhere, right? So you have a whole bunch of warm air. That warm air has a higher temperature. It's going to be low pressure, right? Because those atoms are more spaced out in the open environment. And if it's warm, it's probably evaporating a little bit more water. So it's going to be warm, and it's going to be just probably a little bit wet, right? Not probably enough to rain, not enough really to feel, but just has a good amount of humidity in it over time. So warm, wet air is the lowest pressure air that we can have, right? Is the least dense, and then that least dense air over time, which is right over here, is going to rise. So that air is going to work its way on up into the sky. When that air goes up, remember we talked about cold air coming and taking its place, and it will eventually form a big convection cell, right? That would happen. And so as that air eventually kind of rises in the sky, it gets further and further and further away from the heat source, which is the surface of the Earth on the bottom, and that air starts to cool down. So it becomes more cool over time, and then it's cooling down, the temperature is going down, and eventually, as air gets higher and higher, it gets colder and colder until it reaches the dew point. Right? So that's the temperature at which condensation is going to occur. Right? So it hits the dew point. Right? Once it's at the dew point, condensation will occur, and then as that condensation occurs, it will occur on condensation nuclei. Right? So water droplets will start to form in midair, and they get bigger and they get bigger and they get bigger, and they'll start to kind of refract the sunlight in different ways, and then we see that mass of particles up in the sky, and then that is your cloud. And so for the dew point of the cloud is always right at the bottom of the cloud. Right? That's an easy way of telling the dew point actually in the sky, is because the dew point, if the cloud falls below the dew point, so if this cloud up here were to go down here, well, then that cloud is at a warmer temperature. Then instead of doing condensation, it'll do evaporation, and then the cloud will evaporate and disappear because we cannot see water in a gaseous form. And then, as air goes above that dew point temperature, it gets colder, and then it eventually, relative humidity is 100%, and it will start to condensate in the middle of the air, and then that's how we see a cloud. So sometimes when you take a look at clouds like in the sky, and like it looks like they're like they're kind of moving, maybe like kind of disappearing and reappearing, is that some clouds are going below the dew point, which means that they are evaporating, so they go back gaseous form, you can't see them. And sometimes that air then comes back above the dew point and starts to condensate, and then you can see that condensation. And so then that's how a cloud forms. And we'll do some cloud labs when I get back next week. All right. Hopefully that answered your questions. I have two activities for you to do. They're in your Google Classroom. One is a little bit of review on dew point relative humidity, calculating out with sync psychrometers. That's a Nearpod assignment. And the other one goes into and talks a little bit more about monsoons and thunderstorms, and has some animation games for you to kind of work through, and an article to read. All right. Besides that, hopefully you have a great day, and I'll see you next class. All right. See you later.